So last session we stopped at this place. So we learned that what are dimensions, what are facts, and what are the tables that will be considered as fact and dimensions. So today we are going to start with this slide that is from OLTP to Star Schema. So last session also we have learned about Star Schema. So this time today we are going to see how the OLTP tables are converted to Star Schema tables. Okay, that is fact and dimension tables. So first let's understand what is the grain of a table. So grain of a table means what is the smallest, we can say, grain defines the lowest level of detail represented by one row in a table. So it means that one row of a table represents what? So from here, let's understand if we have an order in one row, we say that it's one row per order. If it's having a daily product total, then we say one row per daily product total. Okay. However, when we are talking about OLTP, right? So that time we have to avoid joins. Hence, what we do, we try to write one row per order line item. It means that one product of that order will be in one line. Okay. We'll talk about this more. So now let's understand. Okay, this we have already understood what are natural key and surrogate key in our previous sessions. Okay, now how to design the e-commerce star schema. So here we are taking an example of Shop Easy India. That is from requirement to schema. We are going to discuss everything, right? So now let's understand here the business requirement. We want to analyze sales revenue, quantity sold and discount amount broken down by product category, customer segment, time period, and delivery location. We need daily, monthly, and quarterly trend analysis. Okay, so here our business process is going to be online sales or order fulfillment. The grain has to be one row per order line. It means that each product of the order will be in a single row individual and identify the dimensions. Here we have to identify what are going to be the dimensions, which we have already done in our previous session, and identify the measures. It means what are the measurable quantity in my fact table. Okay, so this is going to be quantity, unit price, discount, revenue, and shipping cost. Okay, so now let's understand what is my original OLTP tables have. Right. So original OLTP tables have four normalized tables that store the live order transaction before any warehouse transformation. Okay, so if you know, we have talked about this in our previous sessions as well, that we are going to have customers, orders, order item, and products table. So these are the four tables that we have in our OLTP database. I'll show you those as well. So here also we know that these tables are normalized properly. It means that data is split across small normalized tables. So insert, update, delete operations stay fast and duplicate data is minimized. Right? But in analytics, however, we must use join these table repeatedly. Right? So to avoid this, we are not going to have normalized tables in our OLTP. Okay, this is what we have discussed. Right. So now let's come back here. Okay, so how one order is stored in OLTP? It means that here we know that once a customer is created, okay, now let's talk about this one. Okay, so once a customer is created, we see that if the customer has placed an order, if that customer has placed the order, so we keep a foreign key here in the orders table, and order details is there in orders table. So this is the order date and this is the order ID. We know this already, and this is the foreign key, that is the customer ID that we have in the customers table, right? And after this, we are going to store the details of orders in order items, right? So here we are going to have the order ID and the product ID, which is coming from the products table. And here the product ID here is primary key. Here is going to be foreign key. We have seen this already. So this is combination is being stored in order items table, right? So key idea here that the business sees one order, but the database stores it across multiple related rows, right? So one order information, if you note it closely, so here it means that here the just to store one order, we have to store information in 4 different tables. So we are talking about OLTP here. So in OLTP, just to store one order data, we have to insert rows in 4 tables. This is what we have seen. This is OLTP. And why we are keeping like this? Because this is an normalized tables. It means that we are not trying to keep the duplicate data in tables, right? So to overcome this, we are going to use OLAP once we move to analysis, right? So after this, now this is an important slide. Please do not miss on this part. So here what you can see here is we have OLTP source and here we have OLAP as target. So this is the OLTP that you won't be actually writing the queries here. You may or may not, but your work starts after you extract your data from OLTP source. Okay, so we'll talk about that as well. So in OLTP, if you remember last session, we talked about what tables we have right now. So we are going to have customers, products, orders, and order items table. Okay, I'll show you that first. Okay, so here what I have done, if you see here on the left hand side, you will see I have created Shop Easy data warehouse, Shop Easy OLTP database, and this is the staging. So this is the OLTP database that we are talking about, right? So here we have 4 tables. You can see here 4 tables, and because the data or the tables are normalized, just to keep one order detail, I have to insert data in 4 different tables, right? Okay, so now as we know in OLAP databases, we avoid writing multiple joins. Hence, we should avoid normalized tables. Okay, so it means that our source table is having 4 tables here. Source database, sorry, is having 4 tables here. Now let's come back.
Divya,
Yeah.
hello. Yeah, are you sharing screen?
Okay, just a minute. I think I stopped that.
Yeah,
Just give me a
that's why.
minute.
Okay.
Okay, sorry. Okay, able to see, right?
Yeah, visual.
Okay, okay, sorry. So let me start it again quickly. So, right. So from we actually stopped at this place. Last session we stopped at this place. Just give me a minute. Right. Okay, so we stopped at this place here. So today we are going to discuss about designing the e-commerce star schema. So last session actually we talked about what is star schema, right? So today we are going to see how the OLTP tables will be now like redesigned or restructured to OLAP databases, right? Okay, now let's come back here. So business requirement says that we want to analyze sales revenue quantity. Just a minute. Sales revenue quantity sold, discount amount broken down by product category, customer segment, time period, and delivery location. We need daily, monthly, and quarterly trend analysis. So, our business process is online sales that we know. Define the grain. Grain is what? Grain is actually defines the lowest level of detail represented by one row in a table. Okay, it means that initially when we were talking about OLTP, that is transaction database, we were storing you can say in orders table, we were storing one row per order. So in order items table, we were storing one row per product per order. So here in the fact sales table, we are going to store again one the same thing actually this one row per order line item. It means that if order is having two different products, it means each line is going to show one product detail, product one, and then the second product will be in different row, right? Okay, so far I think it's okay. And now identify the dimensions. So last session also we talked about this one, that we are going to have 4 dimensions: customers, product, date, and location. And uh, identify measures. Measures means the quantity that will be used for analysis. So majorly business are concerned about these information, right? How many quantities were sold, what was the unit price, discount, revenue, and shipping cost. Okay, so this is what we have identified. So once we have identified the business requirement, it means that now we have to go ahead and understand our OLTP tables, and based on that we have to understand our OLAP, right? So here, if you note the same thing that I shared just now in our, if you see here on the left hand side, you will see OLTP database, right? Shop Easy OLTP. So this is the database that I created for this session. So I'll be sharing all the create statements and insert statements, but let's check here that we have 4 tables here right now. The 4 tables that we have been using commonly right now. So these 4 tables are normalized tables. It means that we are not storing duplicate data in any of the table. Okay, so now let's come back here. So far it's okay. It means that data is split across small normalized table. So insert, update, delete operations stay fast and duplicate data is minimized, right? But in analytics, however, must join these tables repeatedly. So it means that if the tables are normalized, I cannot go ahead with analysis because I'll have to keep on writing joins multiple times. So to avoid this, I need to restructure the tables. Okay, we'll talk about this. Okay, so now here, let's understand this one. Just to store one order, I need to insert data in customers, orders, order items, and products. This is, we are talking about OLTP. Now let's come back here. Now this is an important slide. So here you can see the same thing. The customers table that was in transactional database, we are using as a dimension table here in OLAP. The products here we are using as a dimension table again. From the orders table, we have picked up the order date here. Now date is very important when we talk about analysis, right? So I just picked up this column and based on this, I created a completely new table. Okay, I'll show you how we are creating. And from this table again, I picked up one column and I created a completely new table again. And then what I'm doing just to understand or just to create the fact table, which is having multiple measures, right? It means that now I'm combining orders, order items, and products. I'll show you how I'm combining 3 tables into a fact table. And I have the insert statements also, which you'll be able to see. Okay, so far I think it's okay. But if you know, we cannot just pick data from OLTP and store it into OLAP. We need to have what? We need to have the raw tables and then staging, and then we'll do like this, right? We can have transform also in between. I hope we know this already, right? So it means extraction, then we put it into raw table, then staging, then transform, and then final is the, this is my gold layer, right? We have talked about this one, right? So here for this session, I am not adding like this raw level here. So directly from here, this is the first and this is the second and this is the third layer. Okay, I'll talk about this. All the steps in between I've skipped, but you cannot skip. You need to have these steps as well. But just for the understanding purpose and teaching purpose, I have skipped these because it will be huge session otherwise, right? A long session. So far I think it's okay. Now let's understand how I'm converting this. We are talking about customers table here. From customers table, we have OLTP, right? How do I convert it to a dimension table? This is very important. So if you note here, we have this primary key already. And here we called it as okay, this is a natural key. Remember the natural key and the surrogate key we talked about. So this customer ID is now a natural key and I created a new key, which is a surrogate key. Okay. Right. So similarly, other things are as it is, and I am just adding some new columns here. That is called enrich, means I am trying to add some new information here. right? Which from where I'm getting, that depends on what is your source. Okay. Now this is table number 1. Table number 2 says products, how I'm converting the original products table to dimension table. So same thing. Here we have primary key and here we have the natural key. And here I created a new key, right? Okay. So, and other things, just give me a minute. Okay. Right. Okay. Yes. So here we have same things. We have here the product name and category and brand. We can get this information from some other table, right? This is called enrich. Now you see some derived also, which will talk about that. So there will be some derived columns and some will be um, what we say degenerate dimensions, which will talk about that. Okay, now let's come back here for the date. For the date, how I'm converting, so this date table is coming from my orders date, right? So what I have done, the same column I just picked up and then I tried to get the values of each of these, the date, month, quarter and year, right? So from the same single value I'm trying to get these information and I've put it in a different columns. Okay, so far I think it's okay. Similarly, for the order placed from column, I have created a new table completely where I have a channel key and a channel name, right? Okay, so these are dimension table because these are telling me the description about the keys that are there in the fact table. So we have just discussed about the dimension table. Now let's come back here. We'll talk about fact tables here. So fact table is going to have all the event and measure, right? Fact means event plus measures. This is what we have seen in our last session. Okay, so here you see degenerate. This I'll talk about. So here, if you note, we are combining 3 tables. We are combining orders. This is 1, order items, that is 2, and this is 3, right? So these 3 tables I am joining and now I'm creating a fact table here. Okay, how I'm combining this? So if you note here, order, these columns are coming from orders table are here already. Okay, and these columns are coming from order items table, which we can see here, quantity and product ID. Okay, I think it's a big table, so I didn't write this one. And then we have product price also. Okay, so all the information will be in the same thing. And then we have some of the keys which are created. So this, if you know, it's coming from the customer dimension, that is dimension underscore customer. This is coming from product and this is coming from dim underscore channel, right? Okay. Date is also coming from date, right? So it means that all the foreign key primary key relationship has been here in the fact table, right? Now what is degenerate and the one that we talked about is derived. What are these two? Now let's come back to our whiteboard. We'll talk about this. Right. So here if you see, we have a derived column and degenerate dimension. So what is derived column? When we do some calculation using existing columns and we create a new column. Okay. So it says that, let's take an example, price band. For example, price band. Price band. So price band, we can say that when the product price is greater than 5,000, then we can say it's budget. Okay, it's in budget category. And when the product price is less than 30,000, okay, it means in between 6,000, like let's say 5,001 to 30,000, it's going to be mid range. Can we say like this? Just an example here. Okay, else we can say it's a premium. Okay, so this is what our segregation here. So it means that this column is being derived from the existing column. So this is called derived column. What does degenerate dimension means? That degenerate dimension is a business identifier kept in the fact table without its own dimension. Now, if you note here, let's come back this one. Yeah. So here, if you see, order ID doesn't have a dimension table for this one. Do we have this? No. Though we have dimension table for all the other IDs, but we do not have for order ID because all the information related to order has been in the same table, right? So it means now this is an identifier but does not have its own dimension table, right? So we call it degenerate. Okay, this is a small difference here. Okay, so now let's come back here. I'll show you one by one. So this is the star schema where we have a fact table here, and then we have all four dimensions table here. So here we have foreign key of all the tables. Here we have primary key, primary key. Here we have foreign key, foreign key, foreign key. Here primary key and primary key. So it means that all these dimensions now are connected with fact table. So this is a star schema. Now let's, this is okay. You can check this slide. Right. Now let's understand important thing that we are going to talk about. Right. So here I have created 3 files which I'll be sharing with you. So here what we have, let's understand. First thing, the first file is going to be the OLTP database. You can just run the create statements, all the create statements, and then you will be able to create these 4 tables. Now this is OLTP database. It means that all the tables are normalized. Okay, so now I'll show you this. I already created. This is the OLTP database, and I have the insert statement, simple insert statement. Okay, so this is very simple to understand. This we have done in our SQL sessions also. So these are very simple. Okay, next step is OLAP or star schema. But before that, we have to actually copy the data to staging. Okay, and then we have to do like this, right? So before this, we know that we have to move this to staging, right? Staging means between OLTP and staging, I need to clean the data, I need to validate the data. So that stage, I have not done this. So that will be needed once you move that to staging. So what I have done for that, I created a completely different database. That is this one. Okay, shop easy staging. So here also, if you open, you will see 4 tables, but this time the name is staging underscore customers. So here the source database is OLTP and target is this one. It means I am getting the data from OLTP and moving to staging. So I'll show you this one, how it's happening. Okay, so the first thing that we have is shop easy OLTP. From here, we have 4 tables here again. And here, from here, I'm moving to staging, where I have again the same 4 tables, but the name is different. And plus it has some extra, you can say some extra columns. Okay, we'll talk about that. What are those? And from here, I'll be moving to OLAP database. Now here we are using SQL Server only just for simplicity purpose, but in real project it will be somewhere in the cloud. So cloud-based database are the one that you have to use here. Let's take an example. Here we have SQL Server. So same thing is possible. The OLTP and OLAP can be in the same database, but ideally it will be in cloud. So that we are not considering here. We are just seeing what will be the star schema tables here, right? So it means here the table name starts with staging underscore. Here it's going to be starting with fact, then dim underscore, right? So it means that first, if we have this transactional database, I need to copy the data from here to here, right? After doing some changes or some transformation, the data will be copied from here to here. Now this time, this is not a simple copy because this time the tables have changed. So here we have 4-dimension tables and 1 fact table. It means 5 tables here. Here we had 4 and here we had 4 tables, right? Now let's come back here. Okay. So, right. So here we have first file is very easy to understand. Staging is doing what? Now here we are creating new tables, that is staging underscore. Okay, so here all the tables if you see are starting with staging, and here if you see I do not have primary key foreign key kind of relationship. I think I've mentioned this one, I'm not too sure here. Okay, so all the primary key foreign key constants I have dropped here. Okay, right. So apart from that, I have added some metadata columns. Metadata columns means, if you remember, incremental load is something we discussed previous sessions. So here we are tracking this based on batch ID. So first load, we are considering it as 1, and later loads we will consider at 2, 3, 4 like this, right? So these are the metadata related to ETL. Then we have products also, where we have the same thing, metadata for products. Load date is very important. Okay. Then we have for orders also we have the same thing. And for order items also we have the same thing. If you note here, the batch ID is repeating in all the tables. It means that this stage itself is denormalized. Okay. So after this, once we create all the 4 tables without any constraints, now this time, okay, if you see the constraints also, no, the keys also, we do not have any keys right now. And here, if you see, everything is allowing null values. So if you want, you can have better constraint, but foreign key, primary key is something which we drop at this stage. Okay, because we are going to create a complete new foreign key, primary key relationship in our star schema. Okay, now load customers from OLTP to staging, right? So it means that here we know the statement that we can use a select statement to fetch the data from a different database. Can you see here what I'm doing? I am fetching the customer's data from OLTP database. It means this one. From here, I'm fetching and inserting in the staging. Okay, this is staging, right? This is staging database. So here it's possible to fetch data from different database and insert to a different database. So I have done this already. I won't be able to run this again. I have already inserted the data. I'll show you that. Right. Similarly, load products from OLTP to staging. Very simple. Again, the same thing. I'm just fetching and mentioning the batch as 1 because this is the first load. I am hard coding this value as 1. Right. Okay. Similarly, I'm loading orders from OLTP to staging. Very simple thing. Exactly same thing. Because I have not changed much in the table structure, hence I can simply insert like this. I just added one, I think, yeah, one extra column, and another is auto inserted. Right. And after that, load order items from OLTP to staging. Okay. So similar thing, order items, it's done like this. Now let's verify our data. Okay. Now let's come back here. Here we have all the data from the OLTP database, and here we have the load date, which is just before this session, 319, and batch ID. Okay. I hope it makes sense. Right. Now, right. So far it's okay. So it means that we are able to load the OLTP data into staging. So now whatever modification we have to do is from the staging to OLAP. Okay. So here the same thing. Now create dimension fact tables for the Shop Easy e-commerce data warehouse. Right. So here now this time I'm creating 4 dimensions, which we talked about, and 1 fact table. Okay. Any doubts from anyone? Okay, right.
No.
Okay. So there are 3 candidates who joined from this account. So I was asking.
Yeah.
Okay. Yeah. So so far it's okay. So fact table grain is what we have understood is the smallest, or you can see the low level data that is stored, the lowest level of detail that can be stored in one row in a table, right? So we are only talking about fact table here because fact table is very important so far, right? Okay, so now let's come back here. It's very easy. I have kept things very easy for you to understand. So this time I have created a new database again. So if you see here, we already have first OLTP database, then staging database, and then data warehouse, this one. So you can change the name also, it's up to you. So I just created like this. And here I am creating 4-dimension tables, the one that we talked about, right? Okay. So, so natural key and business key are the same, which is coming from OLTP system. So one thing to note here, as a data engineer, you won't be required to write the queries in OLTP. That will be the responsibility of application developer. But as a data engineer, you should be aware of what all the tables that you have to deal with. There are some tables which you do not have to deal with. So but you should be aware of the tables which exist in this database, and that is of much importance for you as a for analysis, right? So that is very important here. So work of data engineer starts only after we extract the data from this system. So you won't be having the maybe permissions also to write any query or run any query, right? That is also there, right? So here, now let's come back. So we have this create statement for this dim customer. Okay, so this one, right? So we have customer key, customer ID, name, and email. And here we have extra information that we can pick up from anywhere. Just for showing you this example, I added few extra columns here. This information, if you want, you can have another source, right? So what we are doing here, we have only one source right now, that is OLTP. What if I have another source? From there, I'm getting this information. So all this joining and all has to happen at staging level, right? Okay, so if you want, you can do it staging also, or if you want, you can do it here also, this level also, right? But this information, it means, is being possible to get this information from some other source. Okay, so now let's understand dim product. Dim product is again the same thing, stores descriptive product information, right? So it means we have a product key which I created for this one. Which is a surrogate key, and this is the business key that we have, which is a natural key. And then this information I'm getting from the product table. Again, I created something else, and if you know, let's talk about, okay, right, I'll talk about this one later. And this information also we may be getting from some other source, right? Similarly for date, this time what I'm doing, I am just splitting the date that I have got from a transactional database and picking up values for each of this column, right? I'll show you that as well. And then channel is very simple. Channel means we have the one surrogate key and one column which I'm getting directly from orders table, right? Very simple. These are very simple. And this time we have constraints, primary key, unique key, foreign key, everything is here, right? But here these tables are denormalized, right? So far I think it's okay. Now let's understand. Okay, this is the fact table. Fact table is very important here. So we have again, this is called surrogate key. And then we have degenerate dimension. It means this ID doesn't have any dimension attached to it. And then we have dimension foreign keys, very easy. Then we have measures. Now these are very important, on the basis of which the business use case will be written. It means all the aggregations and all the Windows function that we have learned so far will be on these measures, right? These are measurable quantities. So if you see here, majorly they are numeric and decimal type. Okay, right. And then we have all the constraints, foreign key, primary key are possible here. Some checks also have done. So I ensure that the values are not invalid, right? Now let's understand the loading part. This is very important. How to load the customers from staging. Okay, now here let's understand default, because this is the first time that I'm inserting from the staging. I mentioned this as a null because I do not have this data right now. Okay, maybe I may get this data in incremental load, right? So this is the first load. After that, we'll be having incremental load. We have talked about this in one session. So initially, for the first insert, I mentioned this as null, right? I hope it's easy to understand. Okay, so simple insert is I'm fetching the data from the staging database, from the customers tables, and then I'm inserting in dim customer. Very easy, very simple to understand. Now let's come back here. We have dim product here. So dim product, again the same thing. This time the category and brand is empty. We may get this data in incremental load, which is possible. First time we do not have. Here is the derived column. What is the derived column? We talked about this one just now, that we are deriving this column data from the existing column, which is product price. Okay. Right. So now product price, if you know, is actually in the fact table. If I'm not wrong, but I'll check this one. Yeah, it's I think in the fact table. Yes. Can you see here? It's in the fact table. Right. So we have name, ID, and price band. This this column is in fact table. Right. So based on this column, I am now deciding what is the price band for this one. So this is a derived column. Right. For the date, what I'm doing, simple thing, I'm just using some of the date functions to get the value of each and every year and full date, day, month, and all those things. Just inserting these values in separate columns, right? So I'm using a single order date column and fetching multiple data and storing in different columns. It's very simple, right? Okay. Okay, after this we have dim channel here. So dim channel says that here I need to insert only one column. Why? Because we have channel key, which is a surrogate key. It means it's auto incrementing, right? We have said this one already. So it's auto incrementing. That is the reason. Okay. So this is very simple to understand. Now let's load the fact table. Now this is one of the important thing. Let's come back to this one, how we are doing. So if you remember the slide that we talked about, yes, this one. So here, if you see fact table, for the fact table, no, not this one. Yeah, for the fact table, we are picking the data from orders, order items, and products table. Three tables joined together to insert the data in fact table. It means let's understand what we are doing. We are joining orders table, order items table, and products table, right? So this is the inner join that we have written, and here we have on condition. This we have seen example multiple times. So this here we are putting all the measures here. Now this is very important to understand, right? So if you see here, product price is now just renamed to unit price. The same thing that we talked about, product price is now a unit price. Okay, discount we are giving 0 for now. Okay, I hope it's easy to understand, right? Okay, so far it's okay, I guess. Now this is a complex query. So you may have to write complex query while insertion, but after that, once you write the analysis or business use cases, you won't be having to, it will not be needed to write multiple inner joins. Okay, right. I hope it makes sense. Okay. Okay, so now verify the loaded dimension data. We are checking the dimension data first. Let's try to check. I'll show you all the records here. Okay, so let's understand the customer here. The customer, we have customer key. This is the surrogate key. This is the business key. And we have other information. These are null, which we set right now. Then let's talk about dimension product. Here we have the surrogate key. This is the business key. And then we have category and brand as null. And this is the one derived column that we created. Now let's come back here. Here we have date dimension. This is the date. Okay. And then we have, so here we do not have a key actually. We are deciding the value of this key also. So it's not something auto increment. I'll show you this one. Okay. Yes. So here, if you see here, date key is something that we are inserting like this. Okay. So that also is possible. If you want, you can change that also. No issues. Just for simplicity, I did like this. And the channel key is auto increment. And here you can see the channel names, right? Simple thing. So far, it's easy to understand, right? So once you have these things, Then you can write all the analysis. Remember the business use cases we talked about in our SQL sessions. So those queries now you can write here without using many joins or subqueries. That is possible 100%. You try to run the same business use cases here in the same table, and you will get the answer quickly, right? And you can check the execution plan also from here that we have already talked about, this one, right? Okay, so that is also possible. So yeah, so this was just easy understanding, like how the data is moved from OLTP to staging to data warehouse. In between, we have skipped some of the steps, which is very important. I won't be able to show each and everything in a session, a small session. So here, what we have skipped is data cleaning and data validation. And transformation also, we have not done much here, right? Simple thing only, just we have derived a few columns, but we have not done much transformation here. So this is the simplest ETL pipeline possible, right? Simple ETL. I hope it makes sense. Any doubts from anyone?
Uh, Divya,
Yeah.
so uh, so
Yes.
this is all fact dimensions. So these are dimensional parts are there, no?
Hmm.
So in Azure Data Engineer, so this is required for the load the fact and dimension table.
It's up to you. Okay, I'll tell you one thing. Some of the companies do not follow this naming convention also, but they
Okay.
do follow the schema, what schema they are talking about. So,
Yeah. Yeah.
uh, even if, let's say, because this data engineering process is not followed everywhere completely, but we are trying to understand the best process that is there for data
Yeah.
engineering, right? So it's not 100% that every company following the same thing, but they slowly and gradually take up these changes. Maybe initially you will see some tables are not renamed properly or something like this, but slowly they may be having this in their backlog that yes, they have to go ahead and write a proper process and rename the table. So it's not hard and fast like this, but this is the best possible, and 100% in interviews they will be asking you this.
Yeah.
But yeah, we should be aware of, but we should also be aware of that not every company is following all
Yeah.
the processes,
Yeah.
right?
Definitely.
Yeah.
In interview, no, they have asked how to load your fact dimension table. So these are dimension modeler that work. Yeah,
Hmm.
it's a very important to understand what is degenerate dimension, what is the fact, what is the dimension. These all things are there. And another thing is when we creating this star schema, so which will we load first? Fact load first or a dimension load
No,
first?
dimension load first. Okay, that's important question. So if you remember, you see here the primary keys.
Yeah, yeah, yeah.
So first we need to have the primary key, then only we can insert the
Yes,
foreign
yes,
key, right?
correct, correct,
So that is
right.
the reason dimension has to be inserted first. Okay. Right.
Yeah.
And this is a very simple thing. I mean, 100% once you start
Yes.
working as a data engineer, you will not see only 4 or 5 tables. It's going to be huge. Okay.
Yeah.
So this is the simplest possible flow, which I can explain. But once you start getting a hands-on experience, that it will be a different experience for you. Right.